This video is a brief description about PID control and its application in quadcopters. General applications of controllers can be seen in the stability of airplanes, helicopters, and quadcopters, in cruise control of cars, self-driving cars, in conveyor belts which use robust control, and in home automation such as HVAC systems. Now, what is a PID controller? PID stands for Proportional Integral Derivative, and it is used to compensate the output of a system so it reaches a desired behavior. Now for the effect of the proportional term. This controls how much effort is applied to correct the behavior of a system by comparing the desired value with the actual value. The resulting error is multiplied with a proportional constant to get the output. Now the effect of the integral term. This term accelerates the transition between the current behavior and the desired behavior while reducing the residual error until it reaches zero. It does so by integrating the error over a period of time until this value reaches zero. Now for the effect of the derivative term. This term eliminates possible overcorrection from the integral term by anticipating the future behavior of the error. The output depends on the rate of change of the error with respect to time and is multiplied with the derivative constant. It also reduces the time it takes to reach the desired behavior. Now here is a block diagram of a general PID controller. Now, the application of PIDs in quadcopters. As previously mentioned, one of the applications of PID control is in quadcopters. These can be used for photography, military or police surveillance, package delivery, or leisure. Note the effect of the proportional term in quadcopters is that it is used for flight stability. If your gain is too low, this will lead to a slower response and unsteady or wobbly flight. If it is too high, this will lead your quadcopter to vibrate and oscillate at very high frequencies. However, for optimal gains, this will lead your quadcopter to have a steady and stable flight. Now for the integral term. This is used for the position and orientation of the quadcopter. It is very useful when you are flying in windy conditions. If your gain is too low, this will lead your quadcopter to drift in the direction of the wind. However, if your gain is too high, your quadcopter will have a slow reaction and lead to oscillation. If you have an optimal gain, this will allow your quadcopter to compensate for the wind's disturbance and return to the desired behavior. For the derivative term, it is used to eliminate the overcorrection from the integral term and allows for a smooth and fast transition between position and orientation. If the gain is too high, your quadcopter will once again oscillate. Thank you for listening to this video, and we hope that you have learned a little bit about the application of PID controllers in quadcopters.